Hello everyone, this is me Arijit back with a new video. Now in one of my previous videos I showed you how you can do custom object detection using YOLO V8. Now in that video we talked about license plate detection. So I showed you how you can collect your own license plate data, how you can train the model using YOLO V8 in Google Colab, and finally using that custom model how you can actually detect number plates in any videos or images. Now in this video we are going to do the recognition part. Okay. Now, what is the difference between detection and recognition? Now, detection means, let's say this is a frame and we have a number plate somewhere here. Now, detection means we are only going to say, yes, there is a number plate in this frame. And we are going to say that this is the location of the number plate. So we are going to give a bounding box to the number plate. So we know that yes, there is a number plate and this is the location of the number plate. Now coming to the recognition part, now we are going to take that very particular part, like where the number plate is, and from that part we are going to say that there are like these numbers in the number plate. So let's say the number plate is like ABC123. Now recognition is where we say that yes, this number plate is ABC123. Now we are going to, in this video, I'm going to show you how we can actually do the detection and recognition together. So detection we discussed in the last video, please watch that video for that part. And now we are going to use the same code and we are just going to add few more things in it so that we can do the recognition of number plates too. Okay, now in this video we are going to use Easy OCR, which is a deep learning based OCR library. OCR, if you don't know, OCR means optical character recognition. Now using Easy OCR, we are going to implement the license plate recognition system. So this is all we are going to cover in this video. Now before we start the video, if you haven't subscribed to our channel yet, please subscribe it so that whenever we will make contents like this, you will get update. And now let's get started. Okay guys, so now let's start with the video. Now very first thing is you have to go to our GitHub repo. Okay, now this is the GitHub repo, the link is in the description. Now this is very similar to the last repo where last GitHub repo where we discussed about license plate detection using YOLO V8. Now again I'll say please go to the previous video where we talked about the license plate detection. Okay, how you can do it YOLO V8, the link is in the description. So I'm not going to discuss about how the detection part is working. In this video, we are just going to add a small piece of code in the detection code. So after detection, it can do the recognition. So please watch that video first so you'll understand this video in a better way. Now coming to here, we have just two new files. So one is this license plate YOLO V8 Easy OCR IPONB, which is the file for we are going to use in Google Colab, and then there is this predicted OCR file. Now why we are using Google Colab, you can use the same setup in your computer also, but to use in your computer you need a very good system with a good GPU. Obviously if you want to use it in real time. Okay, but in my Mac I don't have a very powerful GPU, or most of the people don't have very powerful machines, but Google Colab is free and everyone can use it, so that's why I'm using Google Colab. And also not only YOLO V8 but Easy OCR is also a deep learning based library, so that is also it needs very high computing power. So in a normal computer without GPU it's not going to be real time. If you have a good GPU and you have CUDA setup, then only it is going to work on real time. And the CUDA setup, it depends on your operating system. So in your if in your computer you have to run Easy OCR, you in real time at least, you need to have a GPU in your system, and next you should have a proper CUDA setup. Now doing CUDA setup, it depends on the system, either you are in Windows or Mac or Linux. So if you are running the whole system in your desktop or laptop, I would say please do the CUDA setup, watch a video online how to do a CUDA setup. Okay, then install Easy OCR. Installing Easy OCR is very easy, just pip install Easy OCR, that's it. And all the other libraries you need, we have a requirements.txt file, you can just pip install our requirement.txt, will be enough. Okay, but the main thing is the CUDA installation that you have to do. But in Google Colab, you don't need to do anything. It's very simple. I'll just show you here. Now, that is about why you are using Google Colab. So what you have to do is you just have to go to a Google Colab, and there you have to just go to file and you go open notebook. There you go to upload, choose a file, and then you upload this file. Okay, this license plate, this file, and then you will going to have something like this. Okay. Now the very first thing is you have to connect this Google Colab. Okay, you have to connect with resources. For that you have to go to here, you have to go to view resources, and there you have to go to change runtime, select the T4 GPU, because I already mentioned to run it in real time or with fast speed you need a GPU. So use T4 GPU, you click on save, and then you click here connect. Okay, now once you click connect here, it will be connected, and make sure T4 will be written here, so you will know that you have a GPU. And also what you can do is once it connected, you can actually go to view resources and you will see the GPU RAM here. Without GPU RAM also it will work, but it will take a lot of time. Next thing is you have to obviously going to git clone the repo. So you just use it and you will have the repo. So here we have it, this license plate detection recognition. We will go inside this folder. So inside this folder we have all these things. Inside the Ultralytics we have the codes for training and prediction, all those stuff, but we are not going to use those things in this video. And also we have this demo.mp4 file, and this is basically the file we are going to use as a sample. Okay, I'll show you this file. I'll just download this file here. So download. Just give it some time and it is downloaded. So now I'll show you, this is the file we are using. As you can see, quite a bit of, like, we have quite a few number plates in this video. So we are going to apply our model and recognition on this whole video. Okay, also you can just download some random images or videos from the internet. You just put them here and you can apply on them. Next is we have to install, this is the important part, we have to install the requirements. Now the requirements list is pretty big. If you see here, we have a lot of libraries, and for most of them I have mentioned, like here the library version number is mentioned, so that when you install it you will have the exact library number. Okay, and this is it. Okay, another very important thing to mention here is, if you are using this piece of code, this prediction code, or this whole basically this prediction code, I would say, like the detection and the recognition code, your model should be trained using the same Ultralytics version. So basically, so I would say you watch my previous detection video. In that video I have trained my model using this piece of code, so you also have to train your model in this way only. Okay, because if you use some other Ultralytics version, there is a high chance that it's not going to work, because with the version changes Ultralytics, many things changes. So it happens that you train your model in a different version, you take the model and now you are trying to predict on a different model, different version of Ultralytics, and there are a lot of things can happen, so you can get an error. So that's why I recommend you that you only train your model the way I have trained in my last video, then you use this. Okay. So yeah, here the license, all the versions are mentioned. So here we are going to install, here we are going to install, so pip install r requirement.txt, and same thing you do in your desktop also or laptop also, just this line enough, all things will get installed. Okay, so all the things got, okay, not yet, yes, everything got installed. Now we are done, we are installing, we have installed libraries and everything. Now we can actually predict, we can actually detect the number plates and predict, okay, and recognize the number plates. Okay, so get the OCR. Now here is very simple. So we are using predict with OCR file. I'll show you what we have inside this predict with OCR. The model we are using is this base.pt. Now this is the model, I also uploaded this. You can use this model. Now this is not a very good model, we have only trained this model using 400 images and 100 epochs. Now you can use a big data set, you can make a very good model, like a high number of epochs. Okay, and in my last video I showed you how you can do that thing. So in this way you can make your own model, but I'm going to use base.pt, and for demo you can also use base.pt from here. And finally I am going to give the demo.mp4 as a source. Okay, so you can just come here, you can just, if you are uploading a new image, you can come here, you can say copy path and you can just paste it here. Okay, and if you want to use your webcam in your desktop, obviously instead of this source you just have to write 0 without any kind of this quotation, just 0. And if you want a live preview like how it's working, you just have to, at the end you have to write show equal to true. So show equal to true, that you have to write. Now here it's not going to work because this show equal to true, it uses a Qt based interface. Now Qt doesn't work in Google Colab, so it's not going to work here. But if you are running in your Windows, Linux or Mac, it's going to work. Obviously Qt have to be installed, but yeah, it will work. Okay, now I'm going to run this code and it will take some time. Okay, because it will go frame by frame and going to do the recognition, and it is going to save that video in this Google Colab. So it will take some time, and in the meantime I'm going to explain you how the code is working. So let it download the models, and it will start the processing, then I'll show you. So it hasn't started processing the video yet. Let's just wait for a few seconds. It will start very soon. Fusing layers. So yes, it has started. So it will take some time. In the meantime, let's just go to the code and I'll show you what we have inside. Now predict.ocr. Now here in this file, so if you have watched my last video, there is a predict file in Ultralytics. So this is the whole predict file. I have added a very small part in it, which is this get OCR function. Now in this get OCR function, I'm using easy OCR. What I'm doing in the get OCR function, I'm passing the image IM and the coordinates coords. So coordinate means the bounding box coordinates. So like for example, if this is my face, I have a bounding box like this, is going to give those coordinates. Now those coordinates I'm passing, from there I'm getting the XY. So XY and WH. So WH is height to it, and XY is the starting coordinate, okay, or the left top coordinate, you can say, whatever you want to say it. And then we are actually cropping the image from there. So only that very particular part we're extracting. Our confidence we have set as 0.2. You can increase it if you want. Next we are doing grayscale. We are actually converting the BGR, the colorful BGR image into a grayscale image, black and white stuff. And then we are basically sending that grayscale image to reader.read text. So reader.read text, this is basically the easy OCR function read text. Now this is going to take that grayscale number plate image and is going to give us the OCR text. Okay, optical, it is going to do the optical character recognition and is going to give us the text. Now in results we have the text. Okay, and so here one thing is important, that if there is only one result, in that case, so only one text is got, then we are going to return that. Okay, OCR is result 1. So what we got inside the results is basically so there are a few things we got. At first what we get is we get the position of the text. Okay, it has detected. Next we get the actual text, and finally we get the confidence. So in the results is basically an array. So let's say in a frame there can be many texts. So this one text, two text, three text. So results is basically list of those objects, I would say, and one object corresponds to one line of text. Okay, so let me explain in a better way. So just a minute. So here we have ABC, and we have DEF, and we have what is ABCD, GHI. Okay, this is what we have. Now let's say this is the raw image we are providing. Now there are 3 lines. Now in the results we are going to get 3 things. So at first we are going to get this object for ABC, an object for DEF, and an object for GHI. Now in each object, the first thing we are going to get 3 things. So in a list, so we are going to get what? We are going to get 3 lists. So list of lists actually we are going to get. Okay, so list of lists basically we are getting. Okay, now in each list what we are going to get is, the very first thing is the position we are going to get of the text, we are not bothered with the position of the text. Next we are going to get the text itself, so it can be like, let's say ABC, and finally we are going to get a confidence. So let's say 0.9 or something like that. This is what we are going to get. Okay, similar for DEF and GHI. Now if we get only a single result, so there is a single text we got in this way, then we know that this is the only thing we have, so we have to return ABC only, no other thing we can do. But if we have multiple things, multiple lines, in that case what we will check? First we will check if the length of this text is more than 6, not more than 6, I get is yes, more than 6, because that is the standard size of a number plate. And next also we are going to check if the confidence is greater than that 0.2. That 2 things we are checking if I have more than one objects. Okay, so that's we are checking. So if there is only one result, one text, return it. If we have multiple text, so in that case you check if the result is, so the text is more than 6 and then the confidence is more than 0.2, then you return it, return that part. That is the overall what the OCR function is doing. And this reader, if you are wondering where this reader come from, the reader has been initialized here. So reader equal to ECOCR.reader, and inside that we have provided en for English. If you want to do some other language, Chinese or anything else, you can write that thing here. Okay, and I'll show you from where you can get all those things. And also by default, it basically means GPU equal to true. So here by default, if you don't have a GPU, you can actually give comma GPU equal to false. If you don't want to use your GPU, you can give it. But if you have a GPU, you can write GPU equal to true. But if you don't write, it's also okay, because by default it takes true. Okay. And then now that is our get OCR function. Now where we are using that get OCR function, we are using that get OCR function here. So here we basically have the image with the coordinates. So we are passing the image with the coordinates here. So IM0 is the image and XY is the coordinates. And OCR, we are getting the OCR from here using that function, if you remember. And then we are checking if the OCR is empty. So there is nothing. Then no, not empty, sorry. If the OCR is not empty, we are saying level equal to OCR. And if it is not the case, then we are not changing the label. So by default, label will be number plate. If we get any OCR, then we are replacing number plate with OCR. So OCR will be shown in the frame. I'll show you what I mean. Or else number plate will be shown. Okay. And then we are just using this self annotator.box level. This is the code given by Ultralytics, so I'm not getting into it. So this is the part we have added for our recognition part. Now let me show you the result here. I think it's done. Hopefully it's done. Yes, it's done. And the result has been saved in runs detect train. So let's go to runs detect train. So runs, inside that we have detect, inside that we have train, inside that we have the demo mp4, which is the result. I'm going to download this file and it will take some time. Let's wait for it. And then I'll also show you like how you can get more info about EasyOCR. So this is the demo, and here as you can see it is detecting it. And if we take a random frame, as you can see R183JF detected correctly. Similarly, if you take, okay, here it is not detected. Oh, just a minute. So as you can see 8N894JV. Okay, obviously we need a clear frame. In each frame it's not going to do clearly because many things will be get blurred. But yeah, if the license, so as you can see L656XH. So most of the cases, if the image is clear, it's going to give you very good results. Okay. So as you can see, so R66644LX, so H it took as R, but I think in some of the, so yes, now it is correct. So in this way it is doing correct. So basically EasyOCR is as of now, it's one of the most accurate OCRs available in the market. So you can actually check their GitHub file, so like GitHub report. There you will get all the details, what things you can change, what parameters you can tweak, everything. For now, as of now, it's a very good deep learning based model they are using. As of now, they are using ResNet, VGG and LSTM in their model. Okay, if you want to know more about EasyOCR, there is a paper. You can read this paper. You will get to know also. Link of the paper will be in the description. If you want to know more about their model, their training and all the stuffs, the link is in the description. Read the paper, you will know everything. If you want to know how to tweak parameters and stuffs, what languages there, like what the different parameters you can pass, what different languages you can use, check their repo. That link also will be in the description. Okay, and yes, so basically this is how EasyOCR is working. So in this video I just showed you like how we can take our that YOLO V8 detection code. We can add some code inside that. We can add some EasyOCR code inside that very particular detection code, and we can actually do the recognition. Similarly, if you instead of number plate you have something else, you can also use the same logic. But one thing is very important in this technique. So if you are using the same piece of code, if you're using this concept is fine. If you are using the same piece of code, then you must have to train the model with the same piece of code. Okay, now this is not necessary, but if you are not doing it, you can get error. So what I mean by this is like here I am using a very specific version of Ultralytics, okay, while I'm doing the prediction. So similarly, while training, you also have to use the same version of Ultralytics. So if you're using this technique, use the technique I have shown in my object detection video to train your model. Using that code, you train your model. Then using this code, you do the OCR part. Then only you are going to basically you are not going to get any kind of error. And another thing I just forgot to explain you. So basically, if you see, so here in most of the frames it is detecting number plates, so it's not showing. So basically this is the label. So if it doesn't detect any number somehow, then it is going to show license plate or number plate, whatever we have in our training. While training the labels we have said, based on that is going to show us that thing. And if it gets any proper number or string, then only instead of number plate is going to showing this label. Okay. Now the same technique you can use for other things, like I already mentioned, for ID card or anything. Okay, visiting card, any stuff like that, where you have some kind of text. You detect that card using the custom train, like you do custom training to detect that card, and then you use OCR to actually extract that text from it. Okay, so this is how the overall all the things are working. Okay, so that's all about this video, guys. I hope you have learned something from this video. If that's the case, then please hit the like button and subscribe to the channel, so that whenever we'll make contents like this, you will get update. And like I already mentioned, we are already making contents like this. So maybe next we are going to make a video on easy OCR, and then many more deep learning, AI, Raspberry Pi based, IoT based stuffs. Okay, so many things are in the line. So please subscribe the channel and stay tuned with us. And I'll see you in the very next video.